Okay, so sorry about the lateness of this video, but I got a few questions from yesterday and I forgot to do them last night. So on number 4, it says Anna and Montana pass the basketball back and forth with Anna standing directly below the hoop. So I'm going to do Anna, Montana, and hoop because Anna is standing directly below the hoop. The distance HT in feet between the basketball and the hoop. So the basketball is going back and forth, which means our triangle with the basketball to the hoop is kind of constantly changing back and forth along this line. So this distance is h of t equals 7 squared plus b of t squared, where b of t represents how far in feet the basketball is from Anna. So b of t is there, and this is your 7 squared, which tells me that that's constant. So that's changing. So we'll call, so that's okay, we'll just go with this. So h of t squared equals 7 squared plus b of t squared. And this is changing and this is changing. When the basketball is specifically 24 feet away from Anna, so when this number is specifically 24, b prime of t they say, is 8 feet per second, which means it's probably headed that direction because that's a positive number. At this exact instant, what is the rate at which the distance between the basketball and the hoop is changing? So at what rate is this one changing? So we're just going to need to differentiate. So 2 h of t dh dt equals, the derivative of that is going to be 0, plus 2b of t b prime of t. Probably would be easier if we use just like a, b, and c, but we'll just go with this. So at that second, h of t we can figure out by the Pythagorean theorem. What's 7 squared plus 24 squared equals what squared? And that's going to be 25. I'm not going to show that, but you just do the Pythagorean theorem. dh dt is what we're looking for. This is gone, so we've got 2 times 24 times b prime of t, which is 8. So the 2's, divide 2 on both sides, are a wash, and then divide the 25 over. So dh dt equals whatever 24 times 8 is. Must be 192 because I'm looking at the answer. Could do some long multiplication there, but that's it. That's dh dt. Number 5, bear with me because I haven't looked at these yet. Number 5 says, a man 6 feet tall, that'll be him, is walking away from a lamp post that's 24 feet high. Let's do this. We'll call this the lamp post, 24. And this man is 6, and he's walking in that direction away. And his rate is 4 feet per second. So if we have x, y, the rate at which he's walking away is 4 feet per second. At what, oh no, this is 4 feet per second. This is the length of his shadow. Okay, so dx dt equals 4. We're looking for dy dt. So y is to 6 as x plus y is to 24. If we cross multiply, we get 24y equals 6x plus 6y. Get all our y's together, we get 18y equals 6x. And if we differentiate this, we get 18 dy dx equals, dy dt equals 6 dx dt. And we know that dx dt is 4. And so dy dt, when you divide by 18 on both sides, 24 over 18 reduces to 4/3. So the length of his shadow is increasing at a rate of 4/3. At what rate is the end of his shadow moving away from the lamppost? So this is like, so this particular piece is growing at 4/3. This particular piece is growing at 4. So when they ask you at what rate this is moving away, this point in particular, the tip of his shadow, we'll say, is moving for 2 reasons. Number one, because he's walking at this rate. But number 2, because his shadow increases based on the angle with the sun. So when you want to know at what rate this particular point, you're looking to add these 2 together. So 4 plus 4/3 will give you the rate at which this 4 again accounts for the walking speed, and this 4/3 accounts for the length of the shadow speed. And 4 plus 4/3 is, put this over 1, is 12/3 plus 4/3 is 16/3. Number 7 is a kind of a different question. I don't think it's a shadow question, but it's just a related rates question, just I threw on here. The rate of change of the volume of a gasoline tank with respect to time, the rate of change of the volume with respect to time, that's that, dV dt, is directly proportional. Direct proportion. Remember we did inverse variation, direct proportion. So a direct proportion has some constant k to the square root of the volume. K is some constant number. Write a differential equation that describes this relationship. That's it, you guys. Don't even worry about that so much. I understand now, looking at it, why a lot of you had questions on that. A little confusing, but that's the differential equation. And then number 8 I had, which a paper cup has the shape of a cone. So I'm seeing this with a height of 10 and a radius of 3. So no matter where the water level is, the height of the water to the radius of the water is going to be 10 to 3, so we'll use that. If water is poured into the cup at a rate of 3 cubic centimeters per second and leaks out of the bottom at a rate of 1 cubic centimeters per second, how fast is the water level, H, changing? So we're searching for dH dt, but we know essentially that dV dt, they tell us, we have to kind of put it together, but if you're gaining 3 per second but losing 1 due to the leaking, you're gaining 3 but losing 1, that's going to balance out at 2 cubic centimeters per second. So that's our dV dt, really is what we need there. So if we want to make use of this, we have to use our volume formula. Volume is 1/3 pi r squared h. I'm looking for dH dt, so let's keep our h, but let's get rid of our r so we don't have to balance around the product rule and we don't have to work around finding dr dt. We're going to replace r. 3h equals 10r. We're going to replace r with 3h over 10. Before we differentiate. So we get volume equals 1/3 pi 9h squared times that h will be 9h cubed over 100. The 3 and the 9 are going to reduce. So we get 3 pi h cubed over 100. Now we're going to differentiate this. So dV dt equals, we're going to bring this 3 out in front, so that's going to make it 9 pi h squared over 100 dH dt. We know that dv dt is 2. They want to know dh dt at the moment when h is, and I forgot, so I gotta pull up my... Oh no, how fast is the water level changing in terms of h? So we're just gonna solve for dh dt in terms of h. So to get rid of this, to get dh dt all by itself, we're just going to multiply by the reciprocal. So 100 over 9 pi h squared. And that should be our answer, 200 over 9 pi h squared. So they never actually say at the moment the height is 7 or whatever, what's the rate that the height is changing. They just say find the rate at which the height is changing in terms of h. So hope that helps. Let me know. Sorry, a little rough start. I don't go back and watch my videos and remind myself what the heck we're doing. So sometimes when I get into these answers, I'm a little bit rough around the edges because I'm trying to brainstorm and think about how I would do it. Kind of like I do in the notes every day when I'm reorienting my brain. But I think we got it there. Hopefully that works for you, and I'm sure you'll be hearing from me again tonight based on any questions that come up today.